Hello everyone, I'm Nabil and my partner Iqbal. Today, we are going to explain about one of the key primary flight control surfaces, the elevator. First of all, what is an elevator? An elevator on an aircraft is a movable surface attached to the horizontal stabilizer at the tail of the plane. Its main job is to control the aircraft's pitch, meaning it changes the angle of the nose, either up or down. Pitch is crucial for taking off, climbing to cruising altitude, leveling off, descending, and landing safely. Without elevators, an airplane would have a very hard time staying stable in flight.
The elevator is located on the horizontal stabilizer of the tail section of the aircraft and manages the aircraft's pitch angle. This affects flight path and altitude control. Essentially, it's like a seesaw tilting the nose up or down as needed during flight to maneuver the aircraft through climbing, cruising, and descending.
This is how the elevator works. When the pilot pulls back on the control wheel or stick, the elevator moves upward. This increases the tail load, pushing the tail down, and rotates the nose up, causing the aircraft to climb. On the other hand, when the pilot pushes forward on the controls, the elevator moves downward. This lifts the tail and rotates the nose downward, making the aircraft descend. Elevators can be operated through two types of system: mechanical system and electrical control system. First, the mechanical system. Here, the pilot's control movement is transmitted using torque tubes, cables, control quadrants, rods, and power control units. Secondly, in modern aircraft, there is an electrical control system. In this system, pilot inputs are converted into electrical signals using transducers. These signals are then relayed to electronic control actuators, primary flight computers, and power control units to move the elevators. How elevators affect flight stability. Elevators are not just about changing direction, they also help keep the aircraft stable. When the control column is centered, the elevator stays in a neutral position, and the aircraft holds steady altitude. But once you move it, the aircraft's pitch changes. This pitch movement is balanced by aerodynamic damping and longitudinal stability, which means the airplane naturally resists too much pitch movement. Normally, the elevator is adjustable by around 6 degrees to 30 degrees relative to the horizontal stabilizer. Also, the forward movement of the control stick, which pushes the elevator down, usually needs less travel than the backward movement, which pulls the elevator up. This is to allow better climbing control, especially during critical flight phases like takeoff. Elevators provide longitudinal control about the lateral axis of the aircraft. When the control column is neutral, the elevator also stays neutral, maintaining a steady altitude. If the control column is moved backward, the elevators move up, causing a loss of lift at the tail. This results in the aircraft pitching up, assuming a climbing attitude. If the control column is moved forward, the elevators move down, increasing lift at the tail. This causes the aircraft to pitch down, moving into a descending attitude. The elevator is considered a displacement control device. Pitch displacement is always opposed by aerodynamic damping and the aircraft's natural longitudinal stability. To maintain a specific pitch attitude, the control column and elevators must be held in a fixed position. Now let's talk about configuration. How elevators are controlled varies depending on the aircraft type. Traditional aircraft, mechanical system. In older or smaller aircraft like the Cessna 172, elevators are controlled using a mechanical linkage system, including cables, pulleys, rods, and torque tubes. These physically connect the cockpit controls to the elevator surface. The pilot gets direct feedback, and the system is simple and reliable, but not ideal for large or fast aircraft. Modern aircraft, fly-by-wire system. In modern jets like the Airbus A320 or Boeing 787, the elevator is part of a fly-by-wire system. Here, the pilot's control input is converted into electrical signals by transducers. These signals are sent to flight control computers, which then command electronic actuators to move the elevator. This system allows for higher precision, built-in safety protections, and reduced mechanical complexity and weight. Fly-by-wire also supports auto-trim functions, so the aircraft can adjust the elevator automatically to maintain stability. So, in conclusion, the elevator is a small but very powerful flight control surface. It allows the pilot to control the nose-up and nose-down movements, which are crucial for takeoff, climb, cruise, descent, and landing. Without elevators, stable and safe flight would be impossible.